Hi, my name is Miranda Meadows, and today I'm going to be talking about our experiment, What's in the Water. Okay, so first let me give you guys a little bit of background on what we did. Our objective was to identify unknown compounds detected in surface waters using the IR and NMR instruments according to our lab manual. And then, so our IR instrument is, IR stands for infrared, and what the infrared instrument does is it sends a beam through the sample of water, and the beam causes the functional groups in the molecule to vibrate, and those vibrations are measured in inverse centimeters and then depicted as a peak on the graph. I think that it looks like a polygraph. That's how I determine between the IR and the NMR because it has more peaks. And the ultimate goal of the IR is to identify the functional groups located in each molecule according to the chemistry of the text. So a little bit of background about what the NMR does. The NMR, when you put your sample in a tube, you can put the tube in between like two sets of magnets, and the magnets cause the tube to spin, and it creates a magnetic field. And that magnetic field sends a radio frequency through the sample, and that radio frequency is measured and depicted as peaks again on the NMR. And what the NMR is actually measuring is the amount of hydrogens present in that compound and the ratio of the hydrogens that are present. So the goal of the NMR is to tell us how many different types of hydrogens are present and the ratio in which they're present to each other according to range. Okay, so just a little example to show you guys how we did this. In our experiment, we worked backwards, so we used the information that we found from the IR and the NMR to figure out the compound, but this is what the compound tells us that we should see in the IR and the NMR. So this compound right here is methanol, and as you can see, the IR would tell us that there's an OH functional group, and the OH functional group would be in a predetermined range of 3,500 to 3,100. And so we see that there's an OH functional group, and the IR would tell us that. And then in the NMR, we'll see that there's two hydrogens, so there's two different types of hydrogens, so there'll be two peaks, and they'll be in a 3-to-1 ratio, because we can see here that there's 3 hydrogens extending from the central carbon there, and there's a hydrogen extending from the oxygen there. So that makes them 2 separate hydrogens, and we can count them. It's 1, 2, 3 to 1 ratio. So that's just a little bit about how, the information that the compound gives us about what we should see on IR and NMR. And then I will walk you through how we found what our unknown compounds were. So this is one of my unknown compounds, and this is the IR that we got for this compound. And as you can see, based off of these ranges here, that the numbers of the measurements in inverse centimeters of the peaks that lie on the graph correspond to different functional groups. So this one with the arrow closest to your left represents a CH, or carbon hydrogen benzene ring, and there's also 2 peaks that indicate a carbon hydrogen single bond, and then one all the way to your right indicating a carbon chloride functional group. The carbon chloride functional group is a little bit iffy because it's so low on the graph that it's hard to be accurate. So in this case, it can be disregarded, and we can just look at the CH, or carbon hydrogen benzene ring, and the CH single bond. So according to structures of the compounds that we know, we can see that these 4 have the functional groups that were indicated on the IR. So we see that 2-chloropropane, benzene, mesylene, and paraxylene are 4 that we can choose from because they each have a carbon-hydrogen single bond. That one over there for 2-chloropropane has a carbon-chlorine bond, but we can disregard that one. And then these 3 have a carbon-hydrogen benzene ring. So what the NMR is going to tell us is going to narrow down which one of these compounds is our unknown based off of the hydrogen ratio and the peaks present. So this is the NMR result that I got from my unknown sample, and it shows me that the hydrogens are in a 1-to-3 ratio. So based off of this mesylene structure, we can see that There's two different types of hydrogens. The ones in the red are separate from the ones depicted in black. And we can see that there's 3, 6, 9 to 3, which simplifies to a 3-to-1 ratio. And then we can conclude based off of the NMR that the compound, or our unknown compound, would be methylene in this case, because it matches with the IR and the NMR. So we found that it's methylene because it has hydrogens in a 3-to-1 ratio, and there's 2 peaks, which were depicted on the NMR. Okay, so the other unknowns that I found using the same methods were T-butanol and 1,2-dibrommo-2-methylpropane. And as you can see, there is 2 different types of hydrogens in the T-butanol. There's an OH functional group, so the IR would tell us that there's an OH functional group. And right here, you can see that they're in a 3-6-9-to-1 ratio, as it would show up on the NMR. Also, for the 1,2-dibrommo-2-methylpropane, you can see that there are 2 different types of hydrogens, and you can see that they are in a 6-to-2 ratio, which would boil down to a 3-to-1 ratio. And that would be depicted on the NMR with a functional group of bromine for, or carbon-bromine bond for the 1,2-dibrommo-2-methylpropane. So these were the unknowns that I found, and the slide that I just showed you were the structures and how we went about them. Okay, so since we found these compounds in drinking water or surface waters that we would use in everyday lives, these are some environmental effects of what these would tell us when they are found in the water supply. So T-butanol, according to Klink, is highly flammable, and if you're exposed to it for long periods of time, you can have potential damage to your central nervous system. And then 1,2-dibrommo-2-methylpropane, according to the New Jersey Department of Health, they said that it's harmful to animals and people if they're exposed, and it could be suspected as a carcinogen. So if you are exposed to it for long enough, it can lead to diseases like cancer and so forth. And then methylene, which is the example that I showed you guys for one of my unknowns, according to Moderna, it's used in high-grade fuels. So if it's found in the water supply, it can indicate a fuel leakage. And also, just similar to T-butanol, it is like you can have potential damage to your central nervous system if you're exposed to it for too long. So in conclusion, with the use of the IR and NMR, we're able to detect some compounds that can be found in surface water or other mediums, and we would be able to monitor and potentially reduce the devastating effects that they would cause. So here are my sources. Are there any questions?